At some point, you've probably seen a scene in a movie, TV show, or documentary showing an Inuit person wearing heavy fur clothes, standing in front of a house made completely out of snow. And one of the most common questions people ask when they see that scene is, how can anyone live inside a house made of snow? The weather in polar regions is freezing, and snow itself is cold. So how does building a house out of snow help people stay warm inside? At first, it sounds completely illogical, but the truth is, it actually makes a lot of sense. These houses aren't cartoon fantasy. They're real homes known as igloos, and they're still built today by people living in polar regions. In this episode of Detailed Questions, we're answering a simple but fascinating question. How can a snow house be warm on the inside when it's literally made of snow? Before we dive in, if you're new here, make sure to subscribe and turn on notifications so you don't miss any new videos. The Arctic region is one of the most extreme environments on Earth. It stretches from the northern coasts of North America all the way to northeastern Siberia. Despite the brutal cold and harsh climate, one group of people managed to survive there for thousands of years, the Inuit. They're fully adapted to life in the Arctic and completely comfortable with their environment, even though there are no cities, no infrastructure, and almost no signs of modern civilization. Life there is extremely tough. Quick side note, the term Eskimo isn't preferred by the people themselves. It comes from words that historically meant outsider or raw meat eater, which is why they prefer the name Inuit, meaning the people. We're only using the term here for explanation. In the Arctic winter, temperatures can drop to minus 50 degrees Celsius. Anyone living in conditions like that needs shelter. But there's a problem. There's no wood, no bricks, and no metal. Even trees are almost non-existent. So, the Inuit learned to build homes using the only material available, snow. For thousands of years, they've built dome-shaped snow houses called igloos. The big question is, how do these icy structures keep people warm? From a physics perspective, snow can actually be an excellent insulator. To understand this, let's look at an animal called the sea otter. Sea otters live in freezing ocean water and feed on fish. But unlike seals, they don't have thick layers of fat. So how do they stay warm? The secret is their fur. Sea otter fur is incredibly dense and traps tiny pockets of air. Air is a great thermal insulator, which means it prevents heat from escaping the body. That trapped air keeps the otter warm, even in extreme cold. And this brings us to the key idea. If snow contains a lot of trapped air, it can work the same way. The Inuit understand snow better than anyone. In fact, their language has dozens of words to describe different types of snow. One specific type, often called compacted powder snow, is about 10% ice and 90% air. This type of snow is perfect for building. It's strong, durable, and packed with air, which makes it an excellent insulator. That's why igloo walls work like a thermos, trapping heat inside and preventing it from escaping. The interior design of an igloo is just as clever. The floor isn't flat, it's built in levels. The entrance is very low. Above that is an area used for cooking and daily tasks. The highest level is the sleeping area. This design is intentional. Warm air rises, while cold air sinks. So heat from the fire and from people's bodies naturally rises and stays around the sleeping area. Thanks to this system and the insulating walls, temperatures inside an igloo can reach 10 to 15 degrees Celsius. That might sound cold, until you remember it's minus 50 degrees outside. An experienced builder can construct a small igloo in about 3 hours. Larger igloos, big enough for an entire family, can take several days to complete. What's really fascinating is that despite all modern advances in architecture, no one has found a better way to build an igloo than the traditional method. The dome shape evenly distributes pressure, making it extremely stable and resistant to strong winds and snowstorms. And that answers today's question: how can a snow house be warm on the inside when it's made of snow? If this is your first time here, stick around. There are plenty more detailed questions coming up.